Hello. Okay, so for lab, I think I'll call it analog to digital conversion or something like that. I can't remember the exact title. In the past, we've all shared this little board and done some experiments with it, but today I'm just going to explain what it is, and you're going to figure out how to calculate values from it. But what it is this is basically an analog to digital converter, and we got a little 9-volt battery. It's powering it. Um, it's got a bunch of things on here, but the biggest things are I got a power switch and I got all these little switches. And I got this potentiometer. And what this potentiometer does is it adjusts the voltage between 0 and 5. And this is going to simulate having some sort of sensor that's generating a voltage between 0 and 5 volts. So if I flip it on, you'll see a bunch of things happen. I got power light, that's good. But what I'm going to do is I'm going to start out by, I don't know what this voltage is. I've just kind of set it somewhere in the middle. And what we're going to do is we're going to end up with a value called a ADC value, analog to digital value, and from that calculate what voltage is there. And I've got some calculations, and on your homework, you'll use the little table that I've provided in the homework assignment to do this. You won't have to do the flipping switches and all because you don't have one of these in your kit, but I'm going to walk through one and do it, and then I'm going to change the value, and that's going to be what you fill in on your form, if that makes sense. If not, we'll talk about it. Send me an email, whatever you need to do. Okay, so I got this somewhere in the middle, and I'm going to leave it there. And so walking through the directions here, blah, 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 we need to calculate the value. So let me scroll up on my computer, which you can't see, but that's okay. I'm going to set all the switches to 0. So you can see these switches are labeled bit 0, 1, 2, 3, all the way up to 7. And you can see that I can flip them. I can make them a 0 or a 1, depending on the position of the switch. So I've got them all at 0. Then it says flip bit 7 to 1. So basically I'm taking the most significant bit and flipping it to 1. Now, notice this green light lit up. If the green light lights, we flip this back to 0. And then for our 7, we're going to put a 0. That's a 0, believe it or not. If it doesn't light, we'll put a 1. But that one lit, so we put a 0. Now we move to bit 6. We flip bit 6. Bit 6 lit up. So we turn this one back. Put a 0 for bit 6. And I do the same thing with bit 5. Okay, now bit 5 didn't... I flipped bit 5. I don't know if you can see it. Bit 5, yeah. That switch is flipped. The light didn't light. So I'm going to leave this one flipped, and I'm going to put a 1 for 5. Now I'm going to look at bit 4. Flip bit 4. The light lights. Put a 0. Then I flip bit 4 back. Do the same thing with 3. 3 didn't light, so I put a 1. Flip it back. Bit 2. Oops, sorry. Bit 3 I'm supposed to leave. Now bit 2, I flip. It lights. I put a 0. Then flip it back. The idea is if it doesn't flip, if the light doesn't turn on, I leave it alone. Bit 1, lights. Turn it off. Bit 0, lights. Wow, this is the most boring one I could have picked. But whatever. Alright, I'm going to turn this off for right now. Now what I've got is I've got a bunch of bits here. And unfortunately, this was like the worst example because there's only a couple that work. Because this is a 0, we can just put a 0 down here. Now this 1 means there's 1 2 to the 5th. So we put 2 to the 5th is just 32. This is a 2 to the 3rd, so that means there's an 8. It's a 0, a 0, and a 0. So what we end up with is the ADC value is what happens when we add all these up. So you just get a 40. Now, there's this equation, and it's in your notes as well. ADC, number of states, voltage, and maximum voltage. The thing we don't know is this one. So we basically have a ratio. We got 40, and this is an 8-bit, 0, 1, 2, 3, 4, 5, 6, 7. So it's basically 8 bits. So that means we have 2 to the 8 states. And we go up to 5 volts. And we don't know our V. So, working through this, let's see. If I do my math right, I think I get V equals 0.78125 volts. So, now I want to test that. If this doesn't work, I'll probably just have to re-record this video, throw my degrees in the trash, but we'll find out. So go over here, this thing in. I can actually look at the voltage and see. Maybe I can. My hands aren't very steady. Oops, I gotta turn the power back on. And move my fat hands out of the way. There you go. So that's basically what this thing is doing. So, amazingly, it worked for the first time. That's pretty cool. So for your lab, what you're going to fill out on the paper, I'm going to turn this knob to some other position. And I'm just going to walk through each of these. You're going to come up with the ADC value and answer the questions that are in the lab here. So, I've got it turned to some other value. I don't know what. I'll have to measure that later, but I'll do that where you can't see it. And, let's see. 7, 6, 5, 4, 3, 2, 1, 0. Of course, you'll have this in a table, or you make your own table. I don't actually care which way you do it. So starting with bit 7, turn it on, lit, this one, so it's basically a 0. Yeah, 0. 6 did not light, so we leave it alone and make that a 1. 5 lit, so we make that a 0. We turned it off. 4 lit, make that a 0 and turn it off. 3 did not light, so make that a 1. 2 didn't light, so we leave it alone. 1 didn't light. 0 lit, so make that a 0. So you should get something that looks kind of like that. And I'll let you figure out what value that is. Just attach it as like a Word document, or I'll make sure that it's set up to do that. There it is.